Today we're going to get in with multiplicative versus additive relationships. Now we've already gone over our multiplicative, and when we talk multiplicative, we have that constant multiplier, and our equation is represented as y equals a times x. Then with our additive relationship, we're adding or subtracting in here, and y is going to equal x plus a. To determine that a, we've got to figure out what type of relationship's going on. So today we're going to look and see if it's multiplying or if it's adding, and then figure out what that constant's going to be and plug it into our equation. So this is going to be set up with tasks. In the introduction, at Pluto's Playhouse, there are several different games to play. Each game requires a token, and each player can earn tickets. Tickets can be traded in for prizes before leaving the arcade. Task 1. Hayden and Bianca place several different rounds in the two machines below. They determine that machine A and machine B are giving the same tickets based on different patterns. So on A, they put 9 coins in, they get 36 tickets out. Put 6 coins in, get 24 tickets out. On machine B, they put 9 coins in and get 10 tickets out. 6 coins in and get 7 tickets. So I want you to look through here and determine what pattern do you notice for both machine and A? How many tickets would 8 coins produce in each machine? If Hayden and Bianca got 48 tickets out of machine A, then how many coins did they play? What equation could be represented to use how many tickets T were given when C coins were placed in both machine A and B? And what type of relationship does each machine represent? Well, me just looking at the machines, I see going from 9 to 36 is times 4, and going from 6 to 24 is also times 4. So on machine A, I see my my constant is times 4, so my equation would initially be y equals 4x. Now looking at machine B, to get from 9 to 10, I'm going to add 1. And from 6 to 7, I'm going to add 1 here as well. I see on here my constant is going to be adding 1. So my equation would be y equals x plus 1. I also see machine A is multiplicative. Machine B is going to be additive. Now, how many tickets would 8 coins produce in each machine? Well, 8 coins would be considered my input that represents my 8. So for machine A, I'm going to say 4 times 8 equals 32. And on B, I'm going to say 8 plus 1 equals 9. On C, it says if Hayden and Bianca got 48 tickets out of machine A, then how many coins did they play? Well, our 40 tickets out would represent our output. So I'm going to write 48 equals 4x. I've got to figure out what times 4 is 48. On there, my x is going to represent 12. So we put 12 coins in. B says what equation could be used to represent how many tickets T were given when coins C were placed into the machines A and B. So we're going to take what we've initially written up here for our equations, but we're going to replace our x and our y with our coins and our tickets. Well, our coins are the input, so our coins represent the C. The tickets are our output, so our tickets represent the y, and then we can bring down our 4. So for machine A, it's going to be T equals 4C. Now for machine B, my coins is my input, so my X is going to be my C. My tickets are my output, so T goes in place for my Y, and my plus 1 stays the same. So on here, I'm going to write T equals C plus 1 for machine B. And then on E, what type of relationship does each machine represent? Machine is going to be multiplicative, and machine B is additive. Now on task 2, read each scenario below and determine if the scenario describes a multiplicative or an additive relationship. Label each scenario appropriately. So for our Pluto's Playhouse, this one I know that they ordered 7 new games. With that, they added 7 games. So this one here is going to be an additive relationship. On our popcorn, bags of popcorn cost $2.50. On here, every bag of popcorn is going to represent $2.50. So we're going to multiply $2.50 by the number of bags of popcorn. So this one right here is going to be our multiplicative. The cost to go bowling at Pluto's Playhouse is priced at $7.50 for each round. Well, I see a keyword in here, each, and each tells me multiplying. So we would take $7.50 and multiply it per round. That one's also going to be a multiplicative relationship. And on our last one, the number of customers at Pluto's Playhouse is 24. When X number of customers enter, what is the total number of customers, Y? Well, I know X number of customers enter. When they enter, we're adding them in. So we start off with 24 and we're adding the X in. Because of that right there, that tells me that this is an additive relationship. So now looking at the backside, task number 3. Use the tables below to write an equation, then determine if the tables below represent a multiplicative or an additive relationship. So you're going to look at 8 and look and see how you get from 2 to 16, 4 to 32, 6 to 8. Write the equation, determine if it's multiplicative or additive, and then describe how you know. Then do the same thing for B, C, and D. So for table A, our equation is y equals 8x. That is a multiplicative, and I figured that out because all of my x values were times 8 to get to my y. On machine B, my equation is y equals x plus 4. That one's going to be an additive, and on that one I had to add 4 to each x to get the y. On C, y equals x minus 1 or x plus negative 1. That one there as well is an additive relationship, and I subtracted 1 from every x to get my y. And then for my D, to get from 5 to 2.5 and 10 to 5, I took my x and divided it by 2. Division is the inverse operation of multiplication, so this right here shows it is a multiplicative relationship, and I figured that out because I divided by 2 to get to my y. I also want you to look one more thing. I wrote these equations in 2 different ways, but do you see how they're the mirror image of each other? All I did was put my equal sign on the right-hand side and my y. This right here is still the same on both sides. So for task 4, Pluto's Playhouse is looking at new pizza vendors. Determine the equation and type of relationships for each pizza vendor below. Which vendor would charge more to deliver 18 pizzas? So we need to look at these both first and figure out what's the equation, what type of relationship is the equation representing, and then which vendor will charge more to deliver 18 pizzas. Anytime I do these, if I have the graph, I go ahead and write my table off to the sides. And I'm going to put my values from my graph into this table and my values from this graph into this table. Over here, I have 2 goes with 10, 4 goes with 20, 6 goes with 30, 8 went with 40, and 10 went with 50. To get from 2 to 5, I can add 8 or I can multiply by 5. To get from 4 to 20, on that one's multiplying by 5, multiply by 5, and I say that because I can't add 8 to the rest of them. So on here, my A is multiplying by 8. So my equation, or not 8, 5. My equation is y equals 5x, and that right there is showing a multiplicative relationship. Now looking over here on Pizza Planet, I'm going to use my dots. I can go over 2, up 12, so my x is 2, my y is 12. 4 goes with 14. 6 goes with 16. 8 goes with 18, and 10 goes with 20. Well, to get from 2 to 12, I can add 10 or multiply by 6. From 4 to 14, that's going to be adding 10. 6 to 16 is plus 10. 8 to 18 is plus 10. So my equation here is going to be y equals x plus 10. My relationship is additive. Now let's determine which vendor will charge more to deliver 18 pizzas. Our pizzas is going to be our x value, so let's plug 18 in. So on here, y equals 5 times 18. And on here, y equals 5 18 plus 10. Who's going to charge more to deliver 18 pizzas?